Hi everybody, Miss Van Dorsten here. This is my very first physical science video that I've ever made, so I might potentially embarrass myself, and if that's the case, feel free to laugh at me and make fun of me. Also, feel free to pause the video. I'm not going to pause so you can take notes because you can do that yourself. So today we're going to be discussing 5 different types of chemical reactions and then how to identify each type of reaction when the formulas of all the reactants and products are given to you. So before we talk about these different types of reactions, let's just do a little bit of review as to the different parts of a reaction. So you have your reactants. Those are what go into a reaction. So for example, in class, we mixed vinegar and baking soda, and we saw a chemical reaction take place. The vinegar, or acetic acid, and then the baking soda, which is also known as sodium bicarbonate, they are what originally went into the reaction. So that's what you mix together to begin with. Those are your reactants. The chemical formulas on the screen that are reactants are the aluminum atoms and the copper chloride. You know that because they are on the left side of the arrow. So that's what goes in. And then what comes out, those are the products. And in this case, the aluminum chloride and then the 3 copper atoms, those are what come out of the reaction. I wonder if I can move oh, there we go, moving my face up. Okay, let's go on to the first type of reaction. How do I do that? Okay, here we go. So you should have a note sheet that you printed off, and if you don't have a printer, that's okay. You can make yourself a little grid and copy the table that I have for you linked online. It will be very beneficial for you to have this all in one place. So the first one that I want to talk about, oh no, go back. How do I go back? Okay. Whew. The first one I want to talk about is synthesis. Disclaimer, I am going to use relationships as a tool to explain chemical reactions. Specifically, I'm going to use heterosexual relationships simply because it was easier to create slides that way. This is in no way meant to exclude anybody or represent my personal opinion. Love and peace. Okay, so the first one, synthesis. That's when you've got 2 different chemicals, and in this case the people represent chemicals. So you've got Mr. Top Hat and you've got Little Red Bow, and before the reaction they are separate chemicals, and then after the reaction they are chemically bonded together and they are a unit. So synthesis is also known as the get-together. So 2 single people combine into one unit when they become a couple. A more academic way of saying this is when 2 or more chemicals bond together to form one new substance. And then here is the general equation. So you've got A and B separate, and then after the reaction, so after that arrow, you have A and B together. And then here is your example to write in the example box. When you're looking at these examples, please don't worry about the numbers. We're going to talk about balancing chemical reactions, and we're going to talk about why you need the 2 in front of Na and why you need the 2 in front of NaCl. But right now, don't worry about it. So we're just looking at, okay, you've got Na by itself, you've got Cl2 by itself, and then after the reaction, the Na and the Cl come together as one unit. All right, the second type of reaction we're going to talk about is decomposition. So one way that I remember this is that when something decomposes, it breaks down. So that's another way to remember this, but this is like a breakup. So you've got your couple, Mr. Top Hat and Little Red Bow. They're together. They have their happy little relationship for however long, and then something goes wrong and they break up. They break apart. And now after the reaction, so after that arrow to the right, they are no longer a unit. They are separate. So a more academic way of saying this would be that one substance breaks down into 2 or more separate substances. And then here's your general equation. So AB, that is one compound that is made of A and B, chemically bonded together. After the reaction, they separate into two different chemicals. And then here is an example. So you've got hydrogen and oxygen together as one compound, and then after the reaction, one or some of the oxygen separates from the original compound. So instead of having one compound now, you have two separate things. All right, the third type of reaction is called the single replacement, and that you can remember this as the cheater. So Mr. Top Hat and Little Red Bow have a happy relationship until one night they're out on a date and Mr. Top Hat sees Little Black Dress and he's like, man, I just cannot take my eyes off of this girl. That black dress, though, she's looking fine. So he ends up cheating on Little Red Bow. And so as you can see here, originally, right, your reactants, Top Hat and Red Bow are together, and Little Black Dress is single. She's out by herself. After the reaction, Top Hat and Black Dress are together, and Little Red Bow was cheated on, and she's sad and single now. So, one way to say this in a more professional manner would be that one element knocks another element out of a compound. So here is your general equation. You have A and B, they're together. You've got X that is by A itself. After the reaction, this X takes the place of B, and now B is out by himself or by herself. And then here's an example. So this gets a little bit difficult. In order to be a single replacement, there has to be an element by itself. So in this case, you have H and Cl, they're together as one compound, and Zn, which is zinc is by itself. After the reaction, zinc kicks hydrogen out of the compound, so zinc is now with chlorine, and hydrogen is by itself. All right, and then we've got one more with this relationship metaphor. So this is revenge, also known as the swap. So little did you know, but Little Black Dress actually did have a boyfriend. She wasn't really single. The boyfriend just wasn't out with her that night. So Top Hat and Red Bow are together. Black Dress is dating Mustache Man. And Top Hat and Black Dress, they get together because Top Hat sees Little Black Dress out by herself that night. And then in order to get revenge, Little Red Bow decides to date Little Black Dress's boyfriend. So, if you look at this more carefully, Little Black Dress and Red Bow swapped places. So this is when two compounds switch ions with each other, or switch atoms with each other. So you've got two compounds, and part of one and part of the other swap places. Here is the general equation. And here is an example. So let's talk through this example. You have Ba and you have Cl. So Ba and Cl, those are two different atoms, two different ions. And then you have Na, and then you have SO4. So SO4 is a polyatomic ion. SO4 swaps places with Cl because after the reaction, see that barium, the Ba, is now combined with the SO4. And the Cl that was combined with the barium is now combined with the Na instead, with the sodium. So part of each compound switched. and see that this is a double replacement because you don't have an element by itself here. You have two compounds. If you've got two compounds, you can't have a single replacement reaction. Single replacement is only when you have an element by itself. So when Little Black Dress was out by herself instead of with her mustache man. All right, and then the last kind of reaction that I want to talk about is combustion, and I just don't have a good metaphor for combustion, so we're just going to talk about it in terms of science. Combustion is when a hydrocarbon burns an oxygen gas. So you know it's going to be a combustion reaction when you see a hydrocarbon, which is a compound that is made of hydrogen and carbon. And I'll show you an example of that in a second. So when you have a hydrocarbon plus oxygen gas, and oxygen gas is always going to be O2. Oxygen you'll never find in nature by itself, just O. You're not going to find that. Oxygen will bind to itself as gas. So when I say that you have to have oxygen for this to happen, the oxygen has to be oxygen gas, and the oxygen gas has to be by itself. So here's a little bit more information. So you've got your hydrocarbon. So that's the very first picture on the left. The little yellow circles are the hydrogen, and the blue would be the carbon. So that's a hydrocarbon because you have hydrogen and carbon bound together as one compound, plus oxygen gas. And every single combustion reaction is always going to have the same reactants and the same products, at least for this class. So you're always going to have hydrocarbon plus oxygen gas gives me some amount of water, which is H2O, and then some amount of carbon dioxide. So you can pretty much just memorize this equation and be fine, but know that you might have different types of hydrocarbons. So in this case, you have CH4, but you could have a different number of carbons and a different number of hydrogens as long as it's hydrogen and carbon. And I think that is it for today's lecture. Hope it was not too boring. If you guys have any questions, please email me, send me a message on Remind, send me a message in the class group me, whatever you need.